All right, let me add one in. All right, y'all. So 4B deals with some formulas we're going to look at. So the first formula we'll look at is what we call the simple interest formula. All righty, so this formula is A equals P times parentheses 1 plus APR times Y. All right, so A would be the final amount. P is the principal or the starting amount. So basically, P is how much you're investing in this one, okay? All right, then you have one APR. APR is the annual interest rate. Here's the thing about this annual interest rate. If they give it to you in percent form, we got to change the percent into a decimal when we put it in our formula, okay? And then y'all, Y is the number of years. Okay, so I'm going to give you an example of this one. So y'all, for our example on simple interest, you invest $2,000 in an account that pays simple interest of 7% for 20 years. So how much money will you have after the 20 years? Okay, so using our formula, we're going to figure out how much money you can turn $2,000 into if you have a simple interest of 7% for 20 years. Okay, so my P would be the 2,000. That's my starting amount. So 2,000 will be the P. Our annual percentage rate is 7%. But remember, we're going to turn that into a decimal, and then our years will be 20. So y'all, let's plug these in. All right, using our formula, P was our starting amount. That's $2,000. Now we're going to multiply that by whatever we get out of these parentheses. So we got our 1 plus our APR, but y'all remember, APR is 7%. We need to turn this 7% into a decimal. So what you do to turn a percent into a decimal, since there's not a decimal shown on this, it's understood that the decimal is behind that 7. So to turn percent into decimal, we got to move this left 2 spaces. So you would move it left once, add a 0, and move it left again. So moving the decimal left will make that a 0.07. So that's going to be my APR I'm putting in, 0.07. And then that's getting multiplied by Y, which is the number of years. Well, y'all, our number of years is 20. So we put in our 20, and then we're ready to go. So you can push this on a calculator. If you were doing it by hand, order of operations, you got to work inside the parentheses first. So you would multiply these two first, add 1, get that answer, and then multiply by that 2,000. All right, y'all. So I'm just going to punch this on the calculator like it looks real quick. So let me share that calculator. All right, so I had 2,000 times parentheses 1 plus 0.07 times 20 years. Close parentheses. Y'all, once we hit enter, we'll get our amount after 20 years when we started with 2,000. So y'all, looks like after 20 years, we have 4,800. And remember, that was just at a simple interest. Compounded once a year is mainly what simple interest is. It's when you compound it once a year. And so after 20 years, this one has 4,800. All right. Now I'm going to show you the second formula. And this is compound interest. So this is when they compound the interest more than once a year. So y'all, this formula is A equals P times parentheses 1 plus APR divided by N all raised to the N times Y. So A is still the amount. So it's like the amount in your account. P is still our starting amount or the principal. Y'all, APR is still the annual percentage rate. So what's different now is this formula has the N here. N in both places. So this N is what we call the number of compounds per year. So this is when they do it more than once a year. And then y'all, Y is still the number of years. All righty. So let me show you an example of this one. All right, y'all. So on this one, you deposit 5,000. in a bank account that pays an APR of 3%, and it compounds interest monthly. So, how much money will you have after 5 years? Okay, then they also want us to compare that amount to the amount you'd have if interest were paid only once each year. Alrighty. So first let's play with the monthly compounding, then we'll play with the once a year. So let me start out with our formula here. A equals our principal or starting amount, which is 5,000. Then we have our parentheses, 1 plus. All right, remember my APR has to be in decimal form since they gave me percent. So y'all on the side, I'm going to pull up the chat and y'all tell me what is the decimal form of 3%. And then we'll put that right here in our formula. All right, Ashley, good job. 0.03. So we'll put 0.03 in. So y'all should just move that decimal left twice. All right, now let's play with the N for a second. And I'm just going to break some down for you what these mean, okay? So N is the number of compounds a year. So we're dealing with monthly. So y'all, how many times a year would it compound if it was monthly? And y'all, that would be 12 times a year. Good job, because there's 12 months, right? Now, y'all, I'm just going to play with y'all a second, giving y'all some values of N real quick, and then we'll go back to this. So let me ask you this. How many times a year would you be compounded if you were quarterly? All right, good job. That'd be 4. All right, how about semi-annually? So semi-annually, good job. That'd be twice a year. All right, y'all, let's see what else they might do. Daily. So how many times are you going to get compounded in a year? Good job. That'd be 365. So y'all, these are some of the types of compounds y'all are going to get, okay? Monthly, quarterly, semi-annually, daily. Yearly would be one. Alrighty, so what was ours? Monthly. So here where we got these two ends, we need to put our 12. So this will be 12 times Y, which is the number of years. And we are doing this for 5 years. Maybe also let's punch that in and see what we got after 5 years with a 3% compounded monthly. So I'm going to go throw that into our calculator and see what we get. All right, so we had 5,000 parentheses 1 plus 0.03 divided by 12. Then we're going to close the parentheses in this upside down V over here by the divide sign on the right. You click that for exponents. And then that was 12 times 5. Alrighty, also, we got that punched in. We're going to hit enter. And we're rounding it 2 decimal places like money. So that would be $5,808. 0.08. So I'll keep that at 8 since it has a 3 behind it. So $5,808.08. All right, y'all. So that was monthly compounding. Next, they wanted us to do that with annual compounding. So y'all, basically the formula is going to be the same other than the N is going to be different for us. So we still got 1 plus our 0.03. Alrighty, so annual, how much would y'all put for that being compounded annually? All right, one good job. So you're putting a 1 here, and then you got 1 times 5. All right, so let's punch that in and see what we get. So y'all, we had 5,000 parentheses 1 plus 0.03 divided by 1, close parentheses, put in my exponent, which would be 1 times 5. All right, y'all, we hit enter. We get $5,796. And I'm going to keep that 37 since it's got a 0 after it. So y'all notice this. The more compoundings you get a year usually results in a higher amount in your bank. So if you get a simple interest loan, if you invest at a simple interest rate, that's once a year, sort of like this, once a year compounding, you're going to end up with a smaller amount at the end of the year, okay? All righty, y'all, the next formula. All right, y'all. So this next formula finds out how much you got to invest in order to have a certain amount saved. Say you want to buy a house in a few years and you want to have, say, a 30,000 down payment. This next formula tells you how much you got to start with in order to have 30,000 saved after those 5 years, okay? So this formula finds the actual principal that you need to invest, okay? So that A is the amount you want. So that's the amount you want to have saved. Okay. Now we divide that. Basically, we're taking the formula I gave you for A equals and we're rearranging it to solve for the P. Okay. So then you got 1 plus your APR divided by N raised to the N times Y. So all we did was rearrange the formula to solve it for the P, okay? So this formula finds the amount you need to start with in order to have a specified amount after the given time. Okay, so P is still the starting amount you're going to need. A is the amount you want. APR is still our annual percentage rate. N is still the number of compounds. And Y is the number of years. All right, so let me show you an example of this formula. So you want to have 30,000 for a down payment on a house in 5 years. Okay, so how much do you need to deposit now if the bank pays 4% interest with monthly compounding? Okay, so I want 30,000 after 5 years. I need to see how much money I need to put into that bank. They're going to pay me 4% interest, monthly compounding. Okay? So we're going to plug into this formula. This formula finds the starting amount or principal that you need. All right, y'all. So you got your P equals. All right, the amount I want is 30,000. So that's going to be the A. divided by, all right, we got 1 plus. All right, y'all, we got that APR coming up again. We got 4% this time. All right, y'all, so the first thing we got to do, all right, JD, you done got that 0.04. Good job. So, y'all, we're just moving that decimal left again. So we got 0.04 for our APR divided by, once again, we're doing monthly compounding. So that's going to be 12. And then this parentheses is raised to an exponent of our 12 times. And y'all, how many years was this? Oh, right here. 5 years. Righty, so we're going to punch that in and see what we need to invest in order to have that 30,000. So let me go to my calculator. I'm going to clear everything off here. All righty. So, y'all, I'm going to show you a trick if you want things to look like a fraction, like they got. If you hit the green alpha button and the y equals and enter, that brings it up like a fraction. You can put 30,000 on top. Then you can arrow down, put your parentheses, 1 plus 0.04 divided by that 12, close parentheses, and then hit that exponent up and put in your 12 times 5. All right, y'all. So when we hit enter, we will get the amount we need to start with. And y'all, we get 24,570 point oh nine. I'll keep that a 9 since that has a 3 after it. And JD, you're right. That's still a lot. So you have to invest a whole lot of money if you're only getting paid 4% interest at these banks, okay? So, whoo. But I guess in the 5 years you can turn the 24,000 into the 30. Um, but yeah, that's still a lot of money, right? All right, y'all. So next I'll sort of tell you about annual percentage yield. All right, so the annual percentage yield is the actual amount or how about this? It's the actual percentage by which a balance increases in 1 year. All right, it is equal to the APR if interest is compounded annually or just one time a year. it is greater than the APR if interest is compounded more than once a year. Okay, so remember, APR, that stood for annual percentage rate. APY stands for the annual percentage yield. All righty, so to figure out this APY, APY equals the absolute change over the principal. So by absolute change, we mean how much did the account grow for that 1 year, okay? So you'll basically use the formula for A. So right here for the absolute change, we'll use our formula A equals P times 1 plus our APR divided by N and then raised to the N times years. Now, usually when you're finding your annual percentage yield, the Y will be 1 year, okay? And then you can start with any amount for the P just to check how much the bank is going to pay or yield for that year. All righty, so let me see. So let me just show you an example of this. So a bank offers a PR of 2.29% compounded monthly. Now, what's nice on this, since it's a percent you're getting, it does not matter what you start with for your principal. So usually on this one, I'm just going to let my principal equal $1,000. Okay, so by using 1,000, I can see what the bank will yield per year. Okay. Now notice up here we said um, it's greater if the interest is compounded more than once a year. Well, y'all monthly is going to be 12 times a year. So I'm expecting my annual percentage yield to be a little higher than 2.29, okay? All right, y'all, so let's plug in. First, we got to find the absolute change before we can plug into this formula. So the absolute change, to do the absolute change, I'm going to use this formula right here. So A equals P, which was 1,000, times 1 plus. All right, y'all, here's a good one. I need to know what 2.29% is going to be as a decimal. So you got 2.29%. Give me a decimal out of that. Oh, what y'all got? 0.0229. Good job. Right, y'all? We're just still moving that decimal left twice. So now that's going to give me 0.0229. Monthly for my N would be 12 because it's monthly. And y'all, that's raised to the 12 times 1. So when you're looking at an annual percentage yield, you're looking at 1 year for your time on those, okay? All right, y'all, let's punch that in and see what that gives us. And that'll tell me how much the account went up after that 1 year. All right, so I'm going to clear everything off. So we had 1,000. And y'all, when you're looking for the annual percentage yield, like I said, you can start out with any amount, okay? All right, y'all, parentheses, 1 plus 0.0229 divided by 12, close parentheses, and then my exponent was 12 times 1. Or I guess you could have just put 12 since you're multiplying by 1 on that. All right, y'all, we hit enter. We get $1,023. And that's going to be, what, 14 since that's a 1 after that? So in 1 year, this account went up $23.14. All right, so now we're going to plug into this formula because we know how much it changed. So our annual percentage yield is going to equal to absolute change, which we figured out was $23.14. Okay, so the change is how much it went up. All righty. Our principal we started with was the 1,000. So y'all, let's punch that in and see what we get. So 23.14, divide that by 1,000. So I got 0.02314. So y'all, here's the thing on that. This has to end up as a percent. So how could you turn this back into a percent? So if I went left from percent to decimal, from decimal to percent, you're going to go the other way with that decimal. So 2.31 looks good, right? Went right once, twice. So you get 2 point. And I guess since they started with 2 decimal places, we'll make this 2.31%. Good job. Notice it actually was higher yield if you had monthly compounding versus um, simple compounding just once a year. Once a year, you would have had 2.29%. But y'all doing monthly wasn't like a 2/100ths of a point higher, but still it was higher, okay? All right, y'all. So now I'm going to go through some of the problems you're going to see on homework. So let me get moved back up. So this will just be some of the 4B homework examples. All right, y'all, for this one, I want you to rewrite 1% as a decimal. All right, so MATLAB will say 1% equals blank. Okay, so 4B in Blackboard said it was due last Sunday, but in MATLAB, if you look, it's not due till this coming up Sunday. When I change the date in MATLAB, it should trickle over, but for some reason, Blackboard's not updating my due dates and stuff. So all y'all just look straight into where your assignments are. You'll see due dates in MATLAB, okay? Oh, Trinity, good job. That was definitely 0.01. All right, y'all. Write the percent as a decimal. And they got 140%. So this was just getting you good at changing percents and stuff back and forth, so that you can do that APR stuff. All right, y'all. So what are y'all putting for 140% in decimal form? So 1.4, good job. Or you can actually do 1.40. MATLAB will take those either way. All right. So let's go the other way. Write a decimal as a percent. Right. Also, they're giving me 0.83. All right. Good job. Move it right twice and you get an 83 and add that percent. All right, y'all. So let me try a tricky one then. Rewrite 9/5 as a percent. So on that one, you're going to have to take that calculator and figure out what 9 divided by 5 is in decimal form. So 9 divided by 5 equals 1.8. And now that 1.8 needs to be turned into percent out of decimal form. Okay, so 9/5 equaled 1.8. But y'all, we're still in decimal form. We need to turn that into a percent. So you got to move that decimal right twice. So what are you getting up there? 180%. Good job. Oh, yeah, now I'm just going to go back through some more of those interest type problems just to get y'all a little better at them and giving you more than one example on them. So this one's using simple interest. So you invest $3,000 in an account that pays simple interest of 3% for 20 years. All right, y'all, so we're going back to our simple interest formula. And remember, simple interest was A equaled P times 1 plus your APR times the years. So here, our P is 3,000. Our APR will turn that percent into a decimal. And then our Y is 20 years. All right, y'all, here we go. P, 3,000 times my parentheses, 1 plus. All right, y'all, that 3%, I need a decimal. So 3%, 0.03, good job. So that'll be 0.03 in for APR. And then that's times Y, which is the number of years, and that was 20. All righty, so the one of y'all got a calculator, y'all can punch that up. All right, y'all, let me let one in real quick. Right, okay, 4,800, that's what I was getting. And that'll be dollars. So 20 years, if you invest 3,000 at 3% interest, simple, you'll make about $1,800. So not a whole lot because simple interest just don't pay as much as that compounded, okay? All right, also, let me show you another example using the compound interest. All right, so it says use the compound interest formula. So $3,000 invested at an annual percentage rate of 9% for 9 years. Oh, y'all remember my compound interest formula was A equaled P times 1 plus my APR divided by N, and then the exponent N times Y. Now this one asks if the interest is compounded annually. All righty. So we got everything. So we'll plug in now. A equals your P, which was that 3,000, times 1 plus my APR, y'all. That is 9%. So 9%, I need a decimal for that so we can put that in for this APR. All right, 0.09. So y'all, what is N if it's annually? All right, one, you're good, you're good. That's perfect. One time a year. And then it's 1 times Y. And Y was the number of years, which is 9. All right, y'all, let's plug that in and see what we get. So let's get that calculator out. All right, y'all, so what we got? 3,000 parentheses 1 plus 0.09 divided by 1, close parentheses, and then our exponent, use the arrow up, was 1 times 9. All right, y'all, let's hit enter and we'll see what we'll have after 9 years. And y'all look at that, $6,515. Point. Oh, y'all look at that. The 7 has a 9 after it, so I'm going to round that 7 up and make that a 0.68. So you see the difference. While ago, I had 3% interest for 20 years and barely made money. This 3,000 for just 9 years more than doubled because of that 9% interest. Okay. All righty, y'all. So let me find another one that deals with that annual percentage yield. So we're going to find the annual percentage yield in the following situation. All right, y'all. So this one says a bank offers an APR of 4.5% compounded daily. All right, y'all. So remember, I'm going to go back and use the one formula to get my absolute change first, and then I'll put that into the formula for the APY. So you always got to find this first, the absolute change of what happened to your money compounded daily at 4.5%. Now remember, we can pick any starting amount. Usually when I do these, I always start with $1,000. That's one of the easiest numbers to use when you're doing this formula, okay? All righty. So for my absolute change, that's going to be A equals my principal, which is 1,000, times 1 plus. All right, y'all are giving me 4.5%. If we move that twice to the left, we get a 0.045. Check this out, y'all. N. What is N going to be if this is compounded daily? All right, 365. And then that's raised to the N times the years. So that'll be 365 times 1. So it's always after 1 year on this one, okay, when you're looking at the annual percentage yield. So we'll punch this in and then see how much it grew from that $1,000. That'll be our change, okay? So y'all, we're going to go plug that in our calculator. So we had 1,000 parentheses 1 plus 0.045 divided by 365, close parentheses, arrow up for the exponent, and that was 365 times 1. All right, y'all, when I hit enter, the money went to $1,046, and I'll make that a 0.02. All righty. So the change would be that minus 1,000. And this will be how much the account grew during that year. So it grew by 46.02. So that would be the change. All right. So back to the paper. So remember, the APY was the absolute change. Over the starting principal. Well, y'all, the change was the 4602. That's how much the $1,000 went up. So take that 46.02, divide that by 1,000. So y'all let me start on the calculator with that. So it was 46.02 divided by 1,000. That equals 0.04602. So y'all, let me go back to the pad. I need to change that back into a percent. And it looks like I'm going to leave it 2 decimal places. So y'all to go back to a percent from decimal, I'm going to move it right 2 spots so that we basically get 4.60, which would be the same as 4.6%. So notice the annual percentage yield was still higher than the annual percentage rate when it's compounded more than once a year. So this was compounded daily. You ended up with a little bit higher percentage rate than you would have. All right, y'all. So I got one more for our last formula we learned. So let's play with our last formula. All right, y'all. So how much must be deposited today into the following accounts in order to have $70,000 in 8 years for a down payment on a house. Now, assume no additional deposits are going to be made. But this one says an account with monthly, where am I at? With monthly compounding and the APR of 5%. Okay, so y'all on this one, you're going to be using the one where you got to find your starting principal. This formula was the A divided by 1 plus the APR divided by N raised to the N times Y. So we know the amount we want. That's the 70,000. So that's going to be A. The APR was 5%. We'll turn that into a 0.05. N is monthly, so that'll be 12 again. And then the number of years, they want to try to do this in 8 years. Okay? So let's plug everything in. A, 70,000. Dividing that by parentheses. 1 plus, y'all remember 5% was 0.05. And the number of compounds they said was monthly, so that'll be 12. And then y'all, that's raised to the 12 times 8 years. Alrighty. So y'all, let's punch that in and see what we get. I want to clear everything off. Now I'm going to make mine look like a fraction by hitting the green alpha button. Y equals enter. On top, I had 70,000. On bottom, I had parentheses 1 plus 0.05 divided by 12. I'm going to close in parentheses, arrow up for the exponent, and that was 12 times 8. All right, y'all, so hitting enter, let's see what we get. So we're getting $46,961. And y'all, they usually want to round this 2 decimal places. So 4-1, I'm going to keep that a 1 since it's got a 3 after it. So that'll be 0.41. So if you had, that's right around $47,000. But if you invested this $47,000 for 8 years, APR of 5%, in those 8 years, you would have the $70,000 that you want for a down payment. Okay, so if you got money to invest, then you're able to save that for those 8 years and make little money on it. So y'all, they made about 24,000 extra dollars by investing this 46,961. All righty, y'all. So I'm going to give you a preview of our first project. And y'all, you'll find the information on the first project in the week 6 folder. Okay, so what we're going to do is I'm going to pull up a spreadsheet real quick. So let me find it. And you're almost there. Alrighty, so y'all got access to this spreadsheet in the week 6 folder. What we're going to do, we're going to make this Davidson Family Monthly Budget Action Plan. We're going to come in Thursday after I go over 4D. We're going to come in here and fill this sheet out for this Davidson family. And what we want down on the bottom right, the net monthly cash flow, we want that to be positive. So if it's positive, it'll be showing in black. If it's negative, it'll be red right there, red numbers, okay? So we're going to fill out their income and everything, and I'll show you what we're going to go by on that. There's another download for the Davidson family. So it's going to give us information on like his annual salary is 59,400. We're going to fill out everything on our spreadsheet based off of the information they're giving us, okay? And it'll go down through here and it tells us everything we're going to put in there. So what we're going to do, we're going to fill everything out. Usually they're in the red on their budget. So we're going to figure out for our activity what we can do to give them a positive cash flow for the month. Okay, so if you want to sort of look at it before Thursday, um, you can do that, okay? And once I help y'all fill this out, your project will be to answer these questions for the Davidsons, okay? Like, what was the original net cash monthly flow? What percent of their monthly gross income is dedicated to mortgage, homeowners insurance, and county property taxes? What percent is dedicated to vehicle expenses? Okay. Now you don't have to make a slide. You can do it like a Word document or anything. Um, but we're going to come in and figure out what y'all need to put into spaces to get you started on the project. So that will be, so let me bring that back up. So yeah, Thursday after we do 4D, we're going to come in and fill this sheet out so that y'all got something to start with on your project, okay? So this will technically be an activity since we're going to fill it out together in class, and then it'll be counted as a product because you're going to take this and figure out where they can save money and get a positive cash monthly flow, okay? All righty, do y'all have any questions for me tonight?
Hey, you said what day was our project due for the group thing?
So the project, once we go over that Thursday, I'm gonna give y'all 2 weeks to do it. And then
Okay.
what I'll do, I'll put a submission link in Blackboard that y'all can upload it through.
Okay.
So yeah, it's not, and then, so we got to do 2 projects this year. This will be like your first one.
Okay.
Okay. So it's not real bad. But yeah, if you want to be able to get a good start on it Thursday after we do 4D, we'll go through and fill everything out on that spreadsheet so that y'all got something to start with. And then you don't have to actually go through on your own and try to figure everything out. All righty, y'all. So